Hello viewers and welcome to my YouTube channel. We have been seeing a lot on eigenvalues and eigenvectors, and today we are going to see one of the problems which was asked in JAM 2025, IIT JAM 2025. Let's get started. So the question is of eigenvalues and eigenvectors. So the question states that we are given a matrix capital M which has an unknown x, and it is said that x is some real number. Further, if 0 is an eigenvalue of m, then m raised to 4 plus m times of this vector 1 0 1 is equal to, and we are given 4 options. Let's see how we can deal with this problem. So first of all, we are going to use the fact that 0 is an eigenvalue of m. Now we know that since the order of the matrix M is 3 by 3, so M will have 3 eigenvalues. Let me call it to be lambda 1, lambda 2 and lambda 3. And we know by the properties of eigenvalues that the product of the eigenvalues is equal to the determinant of matrix M, that is lambda 1 times lambda 2 times lambda 3 is equal to determinant of M. Now suppose lambda 1 is equal to 0, then the entire left hand side will become 0 and we will be getting the determinant of m is equal to 0. Let us evaluate the determinant of m. It will be an expression in an unknown x. So the determinant of m is going to be, we'll start with this entry, 2 times the minor, which is x minus 0. Then the next entry is 0, so the second term is entirely going to become 0, followed by plus. Then we have negative 1, and this entry is going to be 0 minus 2, so this is going to be negative 1 minus 2. So this thing reduces to 2x, and over here we have plus 2. Thus simplifying this equation, we are going to get that x is equal to negative 1. Now at this point I have the value of x, which is negative 1. So let me just rewrite my matrix. So instead of x, we got this to be negative 1. So now I have the complete matrix M. Now let's get to the other part of the question where they are asking us to find out m raised to 4 plus m times 1 0 1. At this point in time, you should realize that does this vector has anything to do with the eigenvector. And to remind you what's an eigenvector is a vector that satisfies the expression a times v is equal to lambda times v. Here lambda is the eigenvalue and v is the eigenvector. So what we are going to do is, since now m is known and we are already provided v, let us check whether mv is going to be a scaled version of v. So let us talk about the product m times v. So this is m and this is v. So we are going to get 2 0 negative 1 4 1 negative 4 and 2 0 negative 1 times v, that's 1 0 1. Let's take the product. So the first row is going to be 2 ones are 2 and then followed by minus 1. Then the second row is going to be 4 ones are 4 minus 4, and the last row is going to be 2 ones are 2 and again negative 1. So this comes out as 1 0 1, which is exactly v. So in this case we can write this to be as 1 times v. So we can see that m into v is equal to 1 into v, implies that v is an eigenvector and it corresponds to the eigenvalue lambda equal to 1. Thus we already have taken lambda 1 as 0. So the first eigenvalue is 0, the second eigenvalue is 1. Now we can also find out the third eigenvalue using the result that sum of eigenvalues is equal to the trace of the matrix. Now the trace in this case is 2 plus 1, that's 3, plus minus 1, that's 2 again. So this should be equal to 2, and here we get 0 plus 1 plus lambda 3 is equal to 2, and that gives us that the third eigenvalue is going to be -1. Thus we have got all the three eigenvalues. Of course, it is not a part of the question. Now let's get back. So we have that v equal to 101 is an eigenvector corresponding to lambda equal to 1. Now let's talk about the expression that we need. So we need to find out that m raised to 4 plus m times 101, which is v, is going to be which of the four options. So by the properties we know that this addition over here is linear, so this is going to be m raised to 4 v plus m times v, and this can be written now since v is an eigenvector corresponding to lambda equal to 1. M raised to 4v can be written as lambda raised to 4 times v, and m times v can be written as lambda times v. Now for the next part, since we know that lambda equal to 1 is the eigenvalue for the eigenvector v, so lambda raised to 4, we can plug in the value of lambda equal to 1. So this is going to be 1 raised to 4 times v plus 1 times of v, which is v plus v, and that's 2v. And 2 times of v means 2 times of 1, 0, 1. That's going to be the vector 2, 0, 2. And that very well matches with option B. So without any haste, you can select option B to be the correct answer. I hope that this video helps for your preparation. These kind of problems are not only restricted to IIT JAM, they could be asked in GATE, they could be asked in NET as well as SET examination. So keep your preparations up, and if you have not yet subscribed my channel, do subscribe and also like and share the video. Thank you so much for watching and happy learning.